So just a quick review, the equation of a circle. The equation of a circle. Everybody know it? Everybody? Huh? That is the area of the circle. How about the equation if I were to graph it on a graph?
X squared plus y squared equals r squared.
Yes, yes. Not many people remembered that, so be proud of yourself. Did you remember it, Julie?
No, I was gonna say 1.
Okay.
1.
Okay. X squared plus y squared equals radius squared. That's the equation of a circle. Where does that come from? Do you know where it comes from? The Pythagorean theorem. Here's our x. Here's our y. We go x, we go y to get to the ordered pair. And then the radius of that circle would be x squared plus y squared. Not the circle, but yes, the circle, but the radius of the, I'm not saying it right. The hypotenuse of the triangle and the radius of the circle, x squared plus y squared, and then square root that. So that's where all this is coming from. And because we're going to label our sides, we're going to put them on the on an actual circle, we're going to label our sides as x and y now. We're not going to use formulas like opposite over hypotenuse anymore. We're going to say y over r. We're going to use the x and the y and the radius now. So that's what this is right here. This is just showing you the sine is y over r. Cosine is x over r. Tangent is y over x. And then they're your reciprocal functions as well. So then down here, it's talking about if we have a unit circle. A unit circle is just a circle that has a radius of 1. Not all circles are unit circles. If it has a radius of 1, it's called a unit circle. And if so, up here in these formulas, I'm going to replace all my r's with 1. So if I replace y divided by 1, what do I get? Y. So in the unit circle, sine is y. Okay? The unit circle, sine is y. She talks weird. In the unit circle, sine is y. Remember me saying that annoyingness last year? It's just how I remember that sine is y. I like to make them sound the same. Other people have other ways of remembering it, like alphabetically, x comes before y and c comes before sine, or s, or whatever. If that works for you, do it.
Miss G had like a different way that she told us to remember it, but I forgot. And like
So it didn't work.
She brought up your way, and then she said
Sine.
Criswell had like an annoying way to remember it.
So annoying that I remember it. She told me that some of her current Calc students who had me last year are like, remember, sine is y. And then she's like, I know who you had. Anyway, so I do sine is y, and then that means cosine is x, and then tangent is y over x, and they go in order. Like, hi. Like sine, cosine, tangent. They go in order. And then from there we just flip them. So like cosecant would be 1 over y, secant would be 1 over x, and cotangent is x over y. I never have these memorized. I just memorize the sine is y, cosine is x, and then tangent sit wherever. Here. Okay. On this reference angle, we will go over the reference angle because I want to make sure everybody knows the definition of reference angle on Monday. I'm not going to do that right now. I'm just going to jump straight into the examples, and you should know the reference angle thing for the examples, but I think you can still do them about the reference angle. So I'm not going to go over A because I think if you know how to do B, then you know how to do A. I'm going to start with B, and we're going to draw a coordinate plane, and then this says that the terminal side, I could spell terminal side, is the side where the angle leads us if it's 5 pi over 4. So if I say, what's pi over 4, you all should be like, oh, pi over 4 is 45, right? So how many 45s fit in the top half? 4. So 1, 2, 3, there's 4 pi over 4. So one more is 5 pi over 4. So I know where it is. I know it's in the third quadrant. And then the triangle always connects to the main axis, the x-axis. We love that axis so much. It always goes to the main axis. And our theta always goes to the x-axis and the origin. And then we have to find the sine, cosine, tan, all 6 trigonometric functions at 5 pi over 4. Well, we already know pi over 4 is 45, and we just split it up into 45. This one as well is a 45. But all you have to know that's different now is when you plug in your formulas like x radical 2, you have to think about now that the x and the y, when you go to the left, it's a negative number. Or when you go down, it's a negative number. So the only thing new, besides just doing a 45, 45, 90 and finding sine, cosine, tangent, is now location. So if it's in this quadrant, in third quadrant, it's negative, negative for x and y. So when I go to do my sine, and I do the y over the radius, I'm going to end up having a negative number. Now I hope you've done sine of 45 degrees so many times that you already know it, and if not, you're going to have to use your triangle. Who knows that? Radical 2 over 2. We've like done it so many times already. You should know it's radical 2 over 2. The only difference now is it's negative, radical 2 over 2, because in this quadrant, x and y are negative. So anything that has x or y would be negative. What if it's tangent that has both x and y? That would be positive because both x and y become negative and change it into positive. So that's the only difference. The difference about these now is positive, negative stuff. So you're going to try these, and we'll check them and see how you did. And then on Monday, I'm going to do one more example. But on Monday, if you did something wrong, you'll correct it, and we'll work on our assignment in class on Monday and be able to ask questions then, rather than going on and taking more notes. And we'll just on Monday do the rest of this and go over and do homework in class. Okay, just look at C and D. I'll just go to C. We don't have to do both. Oops, sorry. Just C. This is saying that the terminal side is at 0, which is also the initial side. So we don't really have an angle. So if it is on one of these quadrantals on the axis itself, then you're going to assume that this is, actually it doesn't even matter if it's even a circle or not. It doesn't matter what kind of circle it is. It doesn't matter what the radius is. We just usually use 1 for the radius because it's easy, but it doesn't matter what it is. Because what? If the radius is 1, or if the radius is 7, it doesn't matter. What is the x value compared to the radius here? What is this x value? It's the exact same. So it doesn't matter what number you use. We just usually use 1. So what I do is I write this ordered pair as the ordered pair x is 1. What would y be here? 0. It's an x-intercept. Y would be 0. And then we do sine, cosine, tangent, and the other 3. Don't forget the other 3. I'm just hurrying through so I'm not writing them all. Sine is what? Y. Sine is y. What's the y value?
0.
Okay. Cosine is x. Oop, not x. 1. It is x. 1. And then tangent is y over x. So this number over this number.
0.
And that is 0. What happens if you flip 0 over 1? It is undefined. That's the most see. Okay, so all of these are pretty much set up that way. The only other notes that are different are example 4, and actually I already taught you example 4. So those use your calculator, you're sure you know how to type it in. The only thing I want you to do for your assignment is just do as much as you can with these notes, and then we'll check them and make sure you're doing it right. We're not going to grade this. So if you mess up, you'll just be able to fix it. If you leave something blank because you didn't have a clue, we're not grading it. We'll fill these notes in. It's just not, we're not going to spend a ton of time on it, and then you'll have the rest of the time to work on your assignment on Monday. Okay, good plan? Oops. Come on. Do something. I can't stop it. And then these notes are will be on Canvas, as usual.